Hello, my name is Sergio David Bocanegra Garzon. I am here to tell you, this is a presentation, let's call it, for my class, rededes de datos, en la Universidad Piloto. Since I'm allowed to do this in English, I'm going to start by explaining what is Eigrp. Eigrp, or Enhanced Interior Gateway Protocol, like its name implies, is an interior gateway protocol which is designated to be used within a single autonomous system. It was created as a Cisco protocol, but has since then been released as an open standard. The goal is to learn the best route to any given subnet within the network, while OSPF does this by building a map of the entire network and choosing the best route from that map. Meanwhile, Eigrp send updates from one router to the next, like the telephone game. From the perspective of each router, only their neighbor exists. Understand? And it establishes its neighbors, as I like to call it, by first, how do I say this? Sending this signal, let's call it the hello signal, to another router. And after sending it, it determines which is the best signal to establish which is the closest neighbor, let's call it, establishing a direct link between the two. Now, if the back and forth hello signal passes through correctly, they establish a fast connection. Now, and there are these intervals, let's call them. These intervals of several seconds, from 5 seconds up to 60 seconds, for verifying the whole neighbor status in order to maintain the connection. If the interval is interrupted, if the signal is interrupted, like it doesn't send back the signal within these or established interval, then it is removed from the network or loses its neighbor status. Then switches to another router in order to send the signal. I could say it switches to another route. The signal switches to another route to reach another router. Is that a better way of saying it? And oftentimes, let's just say that these routers, they just use these numbers to establish to establish an identity. Yeah. And once these numbers are sent out on the subnet, we identify each of them with these K values in order to identify them. And how do we know these values and these numbers? Well, they're usually identified with something we like to call the autonomous system number, which is set when the configuration of Eigrp when you configure the Eigrp on the router. And hold on a second. Now, we will talk about this little detail. When, let's say, the Eigrp is having trouble with connecting to one of its neighbors, they will do something called route recomputation. This is where the router will try to find a loop-free route to the last subnet. First, the route will enter an active state, which, in spite of its name, means that it's not working. If it's actually working, it will be in a, let's call it, passive state, where it will send this signal to let other, routers know. Well, it's called a query signal to let its neighbors know the problem. And then those neighbors will tell it that they have a route to the next subnet. And they will reply with either a new route to the last subnet or tell them there is no route and that route is dead. So it will be removed from the routing table. That's all I can really say about Eigrp without getting too much into the details of subnetting. I'm gonna pause for a minute and gonna come back with more info about that. Now we're gonna move on to OSPF. Gathers link state information from available routers and constructs a topology map of the network. The topology is presented as routing table internet layer for packets by their destination IP address. OSPF supports Internet Protocol version 4 or IPv4 and Internet Protocol version 6 IPv6. Network and support classes classless interdomain routing or CIDR addressing model. OSPF is widely used in large enterprise networks, or ISIS. Another LSR-based protocol is more common in large service provider networks. Originally designed in the 1980s, OSPF is defined for IPv4 in protocol version 2 by RFC 2328 in the late 90s, or 1998 to be specific. The updates for IPv6 are specified as OSPF version 3 in RFC 5340 in the year 2008. OSPF supports the classless interdomain routing CIDR addressing model. The idea of, let's say, mapping the entire network to find a best route, it sounds awesome and all, but it does sound like it will use up a lot of computational power. Yeah? How do I say this? But you can see the clear difference between this and Eigrp. Because in Eigrp, it uses a more let's call it more direct method of sending in these signals or stopping the signals to find the best routes via connecting the best connected neighbor route. But OSPF appears to be more like sending signals everywhere to map out the network. Now, I'm not exactly an expert on that, but I have found some information regarding some, let's call different topologies to determine which kind of topologies are used in these, let's call them protocols. Now, first I want to explain what is a network topology. A network topology is the arrangement with which computer systems or networks devices are connected to each other. Topologies may define both physical and logical aspects of the network. Both logical and physical topologies could be the same or different in a same network. Yeah? I think the first one we will be talking about here will be star topology. Now, star topology, all hosts in star topology are connected to a central device using a point-to-point connection. That is, there exists a point-to-point connection between host and hub. The hub device can only be of the following: Layer 1, device such as hub or repeater. Layer 2, device such as switch or bridge. Layer 3, device such as router or gateway. As in the bus topology, hub acts as possible single point of failure. Yeah? If hub fails, connectivity of all hosts to all other hosts my throat fails. Every communication between hosts takes place through only the hub. Star topology is not expensive as to connect one more host. Only one cable is required and configuration is simple, really. Now, ring topology, I think the better way to describe that one is, in ring topology, each host machine, let's call them, is connected to exactly two other machines, creating a circular network structure. When one host tries to communicate or send message to a host which is not adjacent to it, the data travels through all intermediate hosts to connect one more host in the existing structure. The administrator may need only one more extra cable. Failure of any host results a failure of the whole ring. Thus, every connection in the ring is a point of failure. There are methods which employ one more backup ring. And now we're going to talk about hybrid topology. Now, hybrid topology, I think, is more familiar to everyone here because, well, let's put it this way. It is a network structure whose design contains more than one topology. It is said to be hybrid topology. But it inherits and, let's say, demerits of all the incorporating topologies. The above picture I just showed you here represents an arbitrary hybrid topology. The combining topologies may contain attributes of star, ring, bus, and daisy chain topologies. Most, let's call it wide area networks, are connected by means. Well, I say wide area networks because saying ones might confuse some people. By means of dual ring topology, and network connected to them are mostly star topology networks. The internet is the best example of a large hybrid topology where these different topologies are interconnected and are forced to cooperate in order to provide the user with a consistent connection, or at least a connection is reliable enough to allow you to let's say do a Google search, for example, and you send the signal out, connects to servers for a whole bunch of places. Well, connects to a, let's say, specific Google server, which then connects in turn to other servers from other companies and services and whatnot to find the best possible results for this search. And thus comes out the results for thousands and thousands of websites. So you could argue that a single Google search has more computational power than, let's say, the computers that calculated NASA's space flights back in the 1970s. I am supposed to briefly touch on the subject of dynamic host configuration protocol, also known as, let's say, DHCP. And in that subject, how do I say this? In that subject, I am going to explain that DHCP is a network management protocol in which is used on Internet Protocol, IP for short, as IP addresses, networks for fully automatically assigning IP addresses and other communication parameters to devices connected to the network. Using a client-server architecture, the technology eliminates the need for individually configuring network devices manually and consists of two network components, a centrally installed network DHCP server and client. Instances of the protocol stack on each computer or device. Sorry with my little mistake. I sometimes make a mistake when I'm remember stuff. I think that's everything I have to say about this part. Now I have to do the exercises with the terminal, where I created my own virtual local area network and used it to input these commands to configure these different let's call them local area networks that I created and GNS3. Oh man, just that I've tried this video so many times, and my many attempts have just resulted in consistent frustration. At this point, I'm just gonna upload what I can, and I don't know, maybe try again next semester or something.